want to see the strategy where you try to get a common base, then I'm going to post the recording of the earlier section, so you'll see that. Let's just hit everything with a log and see what happens. What base would you like to use for this log? Say louder. Let's use 2. One of the exponents is base 2. Let's try it. It doesn't matter what base you use. If you use log base 10, you might get a more complicated looking answer. That's okay. So let's try applying log base 2 to both sides. And this is going to do the opposite of simplifying. This is going to look like it will make it more complicated. With the goal being, this in a perfect world will result in things simplifying courtesy of logarithm laws. So let's try to use those log laws. I see multiplication inside of those logs. What does multiplication inside of a log become? Addition outside of the logs. So I can rewrite these as the log base 2 of 7. That's just like a number. It's pretty close to 3 because 2 cubed is 8. So it's like 2 point something. Plus the log base 2 of 2 to the x. Maybe for the sake of color coding, that multiplication became this addition. Equals log base 2 of pi. That's just some number. It's a little bit bigger than 1, but less than 2. Plus the log base 2 of 3 to the x plus 1. All right, what seems helpful next? Yeah.
Doing the exponentials and log out of the log.
Nice. Whenever you see an exponent in a log, you can make it a multiplier. So this 2 to the x, I guess I have to write everything else down, log base 2 of 7 plus x multiplied by log base 2 of 2 equals log base 2 of pi plus, there's an exponent, x plus 1 times log base 2 of 3. All right, coming along okay? Before we proceed, let's just see if anything simplifies. Are any of the complicated looking things numbers that you just know? Log base 2 of 2 is 1. So that's a simplification. That thing is just 1, x times 1 will just be x, so I can drop that term. All right, feeling pretty good? And let's think about what flavor of equation this is. I see a number plus x is equal to a number plus x plus 1 times a number. So like all the powers on x are just 1, and then I see some things multiplied by it. This is a linear equation. We know how to solve linear equations. We'll like try to rearrange it by adding some stuff to both sides so that all the x's are on one side, all the non-x's are on the other side. Then we'll factor some stuff out from the things that have x's next to them and do some division. Like that's just the general strategy to solve linear equations. So let's set ourselves up to do that. I guess before I can begin, let's do some distribution on this side. Because I see an x plus 1 times a constant. So, log base 2 of 7 plus x times 1 is equal to log base 2 of pi plus distribute x times log base 2 of 3 plus 1 times log base 2 of 3. All right, coming along? So the strategy now is get all the x's onto the same side, all the non-x's to the other side, and then we can factor and divide. So, I guess we have a choice. Should we try to get all the x's onto the left or all the x's onto the right? All the x's onto the left? All the x's onto the right? Doesn't matter, right? We just need to pick one. I think the left's had more hands, so let's get all the x's onto the left. So I guess that means I want to subtract this to the other side. I want to leave the x that's already on the left on its own. So I'll see x minus log base 2 of 3 equals, these two terms should just stay put. Log 2 pi plus log 2 3, and I need to subtract log 2 of 7 to the other side. And if I then wanted to compose this into a write-up that would be finalized, I'd really want to get a clean piece of paper at the end and just arrange everything phonetically, but I'm stuck with the amount of space that this piece of paper gives me, at least for this write-up. Oh, shit, there should be an x next to this, times x. All right, cool. All the x's are now on the same side? So let's factor an x out of all the things that have an x next to them on the side that has a bunch of x's. That'll give me x times 1 minus log base 2 of 3 times x. So log base 2 of 3 equals the stuff on the right-hand side. And maybe now, for the sake of ease, I'll just use a ditto mark. The right-hand side of the equation is staying the same. Nice. So, what's the only thing I have to do next to get x on its own? Divide by the stuff next to the x. Cool. So x seems to be the stuff that is currently on the right-hand side. Log base 2 pi plus log base 2 3 minus log base 2 7 all over 1 minus log base 2 of 3. And I'm low on time, so maybe I'm not that low on time. Those steps were complicated. If you were doing all this on your own, what do you think the chances are you'd have made a mistake in one of those steps? High? So that means it's important to check the final answer to see if it looks reasonable by doing something that doesn't have to do with the individual steps. What's something you could do to check this? Let's graph. Let's graph the original equation. So I guess graph both sides of that equal sign. And then get a decimal approximation for this thing. So, let's do that. Close this. 7 times 2 raised to the x. I want to know when is that equal to pi times 3 raised to the x plus 1. That plus 1 is in the wrong place. All right. It looks like there is one place where those two curves cross. There's the x value. I have an exact value for what that thing should be. Let's see if it agrees. Log base 2, god damn it. It's log base 2 of pi plus log base 2 of 3 minus log base 2 of 7 divided by 1 minus log base 2 of 3. That looks like it agrees with the x value where those two curves cross. Now does it look like the x value where those curves cross? Desmos didn't want to let me put the things in the exponent that I wanted to. So, now that that's corrected, I think I believe this answer. Yeah. Yeah, you could have. Right, like,
Like in the beginning of the problem. What if you want the example?
I would want, as the solution to this problem, I'd be happy with it as written. But there are many different forms that the answer could take depending on like what process you follow. So like, even right now, like I see that those two could be multiplied together to a single log. And then the whole numerator is a single log. The whole denominator could be a single log. If you had done something other than base 2, it would look different too. So, yeah, there are some things that I could do to simplify this stage.
Can you help me plug the U values into the quadratic function? That's like the only thing that I wasn't really getting. And it's like by the time,
Oh, sure.
and it's like I couldn't understand it in time.
So you are happy getting there?
Looks like I wasn't. I don't know where the -4 is coming from.
Oh, it's this minus 4.
Okay.
So I just tried to copy down this. So there's the equation that I need to solve. I'm using u equals 3 to the x.
What about up here too?
Oh,
'Cause
yeah,
I didn't
yeah.
really get it up there either.
Yeah, so I'm using u equals 2 to the x.
Mm-hmm.
So that means I can replace that 2 to the x by u.
Yep, and I have u squared plus u minus 1 for that.
So this is where this 2 to the x became that u.
Yes. U squared minus 1, and then it's like, so given this, how do I plug that in to get that?
Oh, sure. So this is a quadratic equation.
Yeah.
So
But, so I started putting just, isn't that A, B, and C?
yep. So b is 1. So u equals negative b plus or minus the square root of
Is U B or is -1 B?
the coefficients are a, b, and c. So that's 1 u
Oh,
squared plus 1 times u minus 1.
Okay.
So a is 1, b is 1, c is
I can't
negative 1.
believe I forgot that. God damn it. Oh well.
No,
Thanks for that.
it's much better to make that sort of blunder in class as opposed to like on a test or something.
I have class during your office hours every day. Do you have like tomorrow, is there a time you could maybe meet or something? I just have some questions, I need some help with some stuff.
Yeah, tomorrow 8 a.m. is taken, so I'm not gonna give you that time.
Yeah,
There's usually a meeting right after this class on Thursday, but there is not tomorrow, so how do you feel about 11 o'clock?
like just meeting with you?
Yeah, at 11 o'clock upstairs in my
Yeah,
office.
that
Awesome.
works.
Yeah, yeah, then just come talk to me right after class and remind me that we had this conversation and we'll go talk. Yeah. Whew. Sorry, Rob.
Okay.
Okay, stop.